Welcome to Natural Habitat Adventures, Daily Dose of Nature. I'm your host, Sunny Vanderstar. Today's topic is citizen science, everyday people, extraordinary discoveries. And it will be presented by our fabulous NatHab Expedition Leader, Kristina Disney. Kristina, thank you so much for being here today. This looks like a fascinating topic. Let's go ahead and dive in.
Thank you so much, Sunny, and thank you for everyone for joining in today. I love it when I realize how much my worlds overlap. So when I'm not guiding for NatHab, I'm a PhD student at the University of Victoria, and in different vocabulary, a big part of what I do is citizen science. So to start us off today, I wanted to show you the very everyday people, the very wonderful community that I work with in a small watershed called Coxsila. And yeah, I guess this was from maybe 1 or 2 years ago. And these are people that are concerned and interested in the health of their watershed and have found a way to start piecing together some of that information for themselves. And so I think citizen science comes in and out of the world so many different ways under different names as well. And I wanted to use this time, and I'm so appreciative that NatHab opened up its doors to it, because it does tie into so many of our core values and what we believe conservation and how this world should be cared for. It's all really intrinsically linked, and because it comes down to what you want to put energy into, what you want to invest into in your day-to-day life. And so I hope I can kind of tie some of those threads together, maybe in a nice bow that will package this or find its way into your own life, into your own everyday experiences. So I wanted to kick us off because I also love language and understanding words. So even just picking apart, what does citizen science actually really mean? So the term, obviously not the two separately, but that as a single term is really quite new when we think about it in our language. It was only accepted into the Oxford Dictionary in 2014. So really new, actually. And the definition that they give, which again differs a lot depending on who you talk to, but in the Oxford English Dictionary, it is a scientific work undertaken by members of the general public, often in collaboration with or under the direction of professional scientists and scientific institutions. So it just means people doing science, but it's slightly more complicated than that, or maybe depending on how you want to look at it, because that's the definition that's in the dictionary. But even when this term was invented or started being used in the scientific community, which was only really in the mid-90s, there was two people that actually came up with the initial definition. And as true things in science, if you know you're on a good idea when it's being co-evolved in different places. So there was one gentleman by the name of Alan Irvin. He was in the UK, and there was another guy by the name of Rick Bonney, and he was in the US. And the two of them, within really, in science terms, not very long, but within a few years of each other, each defined their own version of what they thought citizen science can and should be. So in Irvin's mind, he thought about it as to develop concepts of scientific citizenship, which the foregrounds of the necessity of opening up science and science policy processes to the public. So what he was after was that science should be responsive to what people are concerned about, and that people themselves should be able to produce reliable knowledge. So that was right. And even that, so he has one definition, but it's this twofold thing, that we can contribute to it, but also that science should be responding to the concerns of the people as they're living and breathing, right? Not always these faraway projects or these faraway notions. And there's room in the world for both of those types of science. But there's definitely a calling for one that is responsive to our needs in real time. Now, Bonney's definition, on the other hand, I think was a bit more of what a lot of people, in my mind, think of when they think of citizen science, which is that it is projects within which non-scientists, amateurs, etc., are able to produce reliable data and knowledge, right? So I think that's more the cut and dry version that a lot of people, when I say citizen science to them, and it's actually one of the reasons why in my own work I avoid using these words, because they have a lot of connotations behind them of what people think it is and it can and should be in their lives. So I want to break it down. I'm going to pull those two words apart, and then we're going to sandwich them back together just to show that I think this does fit into everyone's lives. And you'll have to forgive me, because anytime I have a chance to use a quote or reference from Lord of the Rings, I pretty much always will. What does it mean to be a citizen? You may or may not define yourself within the nation, within the group, within the territory, province, state, culture. But bottom line, and this is where I think they said it best, is that you're part of this world, aren't you? Whatever level of that citizenship you want to identify with, at the end of the day, whoever you are, wherever you are listening in from, you are part of this world. And that makes you a citizen of it in some respect, in some regard. And I don't think it needs to be really much more complicated than that. Some part of it we are obligated to take care of. So if we can keep that one some nice and simple, I would argue that the science one is doubly complicated. What is science? Science is what I've currently devoted my life to, and even I sometimes had to go look this up. I had to go get the cue cards to figure out what actually is science, right? Well, we, in the older definitions of it, and this is another such important thing to remember, just the same way that the things that we know change, the words, the very meaning of them changes with time too. And so our use of them and our concepts, all of that changes along with it. And so the archaic form of science is simply a body of knowledge, or a knowledge of any kind. That's as simple as it was. Now, we've trumped up that definition quite a bit. And this is a much more common, I guess, definition you would find when you go to Google it now, which would be the pursuit and application of knowledge and understanding of the natural and social world following a systematic methodology based on evidence. So you pursue it, you apply it, it's systematic, and you use evidence, and you're trying to understand something. That's what science is. And so what I want you to take from these two definitions is that science is both the body of knowledge that you create and the process of creating it. It's this duality, which can be really complicated, and I'm also going to say also can be very dangerous. And I hope you'll give me a few minutes to explain why I use the word dangerous. But first, holding those two things in one, a process and an actual body of knowledge, the knowledge itself and the process. So I'm going to use a real sciencey example, and I'm going to use a little bit more fun example. The super sciencey example is light. When we think and understand light, we think about it both as a wave and a particle. And you can understand it each ways, and both is true, but it also doesn't quite fit perfectly in either. And even this thing that is literally ubiquitous around us, is lighting my room, is lighting your eyeballs coming in from whatever screen you're watching me from. You have to hold both of those things as true to get a kind of understanding of how it works. But even then, it's not perfect. This is what our understanding, our science, and what we've learned about light has gotten us to. So you have to hold two things in once to keep it functioning. Now, another way I think about this as far as being the body of knowledge and the process is the difference between, are you worried about the actual way you've created something, or are you worried about your end result? So this is a really cute example of an art project for children, right? So product art is, this is what you're going to make, this is the final thing. You need to make a pumpkin. Process art is, here are some paints, here's a picture of a pumpkin in front of you, paint it however you want, right? And both of those create value in a very different way. Product, right? The value of what you hold and know to be true. 2 + 2 is 4. 4 is the product that you hold on to, and that has value in your life. It certainly does, right? But how did that child get that? Or how did you get that? Did you do it in your head? Did you use a calculator? Did you grab 4 apples and count them and bundle them together? The process of how you did it will drastically change the value you associate with it. And so we're getting a bit meta here, but science gets all this bluff and bluster around it. And at the end of the day, we've kind of trumped it into something I think it doesn't need to be. We've separated it from ourselves, and it's grown into this big thing. It's grown into this otherness. And we can take a look at that even through history, right? If you think of who are the great we even just the phrase, who are the great scientific minds of our past, right? I think that's actually a terrible way to box science, because science, as great a discoveries or as great contributions as these people made through human development, science didn't start with these people. It started in all cultures, all around the world, respectively, as people just figured out the world around them by repetition, right? By understanding something, by building off of experience, and things co-evolved in multiple places, multiple times. Things were lost multiple places, multiple times. And so science doesn't begin in a textbook. It doesn't begin anywhere far away. It begins, it's in our past. It's certainly in our present. And I would say for each and every single one of us, not on a big systems level, but on a personal level, this is where science begins. It begins when you're little and you start questioning how your world works, and you start getting curious, and maybe you put things in your mouth that you shouldn't have, and maybe you make a giant mess only to find out, right? The smallest thing, you come home soaking wet from jumping in a puddle and building those little dams as you watch the water flow through to a different spot, right? That's you learning about gradients and elevation. It's all in there. It's just not named. And so one thing, this is the grand scheme of science. And the thing I most appreciate about citizen science is that we're trying to we're trying to either pull some of that otherness away and pull science back into real life, back into everyday life, because we're doing it anyways. We're taking in information, we're making decisions about it. But what we share and what we do with those observations and what we do with those discoveries is what puts science on a shelf or just puts science in your backyard. So thank you for putting up with my slight theological or my theory rant. I promise we'll dig into a bit more, but it has value. It has sort of a sounding board, because we need to understand how we get to this concept in order to understand where it can take us. So I will say, in that sense of what you would think of, what most folks think of when they think about citizen science, if I do want to take a little meander through history, we can go back a long ways, right? So we think about everyday people collecting information for the betterment of themselves or for others. A really cool example that's 2,000 years old is locusts. And so one is from China, the idea that there's these locusts that come and ravage farms, ravage fields. And so their migratory patterns have been reported by communities throughout China for a couple thousand years, which is an amazing set of data that was carried through, right? And so that is everyday people monitoring, timing, exacting, right? They're monitoring their environment, which is 100% a form of science. Now, science is, again, if we start to think about that science that's been put on the shelf, that way of approaching it or digesting it kind of came around in the 1600s. And it's this idea of aristocrats, really, or gentlemen and gentlewomen, educated people who didn't have other occupations, starting to do it as a hobby, right? And this is, again, where we start to see that segregation of science from life, because who can afford hobbies? People who are not necessarily having to spend all their time and energy creating food and sustenance and things like that. So this is where it gets associated with class. And I would say this is where things start getting a little shaky in my mind. But also, you have that time. You have that time to pursue other things. So it's a blessing and a curse in all things. So those people, right, this quote unquote hobby is kind of the foundling of our citizen science. Now, the 1800s is where it really blooms and takes off, right? Start thinking about some of our big discoveries then in biology, in understanding our weather systems, things like that. Because these people are it's starting to grow, and also it's starting to become more along the lines of professionalism, right? So it's now science is starting to become a career. And so it's going to change how science works. It's going to put it in a different section of its own. And I would argue that stayed very true, really, for the next couple hundred years. And I would say that it stayed very similar, or there hasn't been a huge change in our concept of how citizens and science interact until the early 2000s. And what happens then, among the millennia and among, changing styles, is that open data and open science is starting getting pushed to the forefront of this is the way that we should share, communicate, and understand information. So what do I mean by open science? It's the idea that you're sharing everything. There's not this propriety if you create knowledge, it's meant to be shared and to be used by others, right? And when that happens, and we have technology developments, we have our smartphones, everyone has, a computer is no longer something that calculates the space or the distance from us to the stars. It's something that sits in your back pocket. That's a whole lot of power and access to a world that really wasn't there before. And so I'm sure everyone says this about their own respective generations, but I certainly feel, or at least want to acknowledge, that this is a very different era of science that I've grown up in than I would say my predecessors coming before me, than the generation before. So that brings us now to, if we understand where the ideas have come from, where it's brought us through history, and that the idea is that we can connect people back to their science, let's jump into what are some of the existing projects that are out there, and what are some of the eventual or hopeful ways some of you might decide to connect with science in different ways. So this is an example from NOAA. So this one is a marine focus, right? But this is just a few different examples of ways to be a citizen science. You can track the tides, you can monitor debris and hopefully collect some of that debris, right? Watching for whales, geocaching, taking water samples for algal blooms, even just that volunteering at different sites and putting that time in and, recording with those entities the time that you spend there, that can make a difference. But I will say that you don't have to start from scratch. There are projects that have been out there for literally decades or centuries, into a century now. And I want to give a nod to anyone out there who happens to be a birder, because birders have definitely been on the forefront, I would say, of citizen science as we know it today. So shout out to you, to your birding culture. You have done some great work, and I'm really excited to highlight some of the long-standing projects that birders have kept going since late 1800s and into 1900s. Excuse me. So one of the oldest citizen science projects that exists out in the world is the North American Bird Phenology Program, and it started in the 1880s and it went consistently until the 1970s. So there was just about 90 years of data there, and it's handwritten observations, because again, we're going pre-computers. During that time, they made over 6 million records of over 800 different species, which is incredible. Now, I told you that it stopped in the 1970s, and one thing I think is amazing is that they revived it in 2009. And part of that revival is not only continuing the program again, but it's actually transcribing all of this data into a digital form so that it can be used in scientific process. And who is doing that? Not just, it was volunteers that spent 90 years collecting it. It is now citizen scientists who are also transcribing that data, right? So even if you're not able to, get out in your backyard for a while, or maybe you're stuck in an airport waiting for a layover, you can log in and transcribe, 5 slips if you wanted to for the hour. And I just think that's such a cool connection, right? Connecting past and present, but also bringing that data forward and having it being the citizen scientists collected it, and now also the citizen science that's bringing it back into the realm and into our use. The other thing I wanted to point out, so this is a copy of one of the slips, and if you look, there's really not a lot of specific detail on there. It's the bird species, the county that they saw it in, who saw it, the time, and whether it's common, not common. But there's just the last sentence, right? There's a little space there for observation. And I love the simplicity of this, but I also love the impact of this. Most common when apple trees were in bloom, right? That makes sense in a lot of ways. But think about it. This is just an offhand comment, but if you have literally hundreds or thousands of people who are noticing their world, who are outside, right? You're in your yard, and it doesn't take much, right? Like even I think about myself, like biking to school. I know when the acorns drop, and I can keep track of that. And right, there's these things that we intuitively know, and that value, it has value to us. But those things that we intuitively know that we tie into our natural world can have even greater value if we gift them up and into a bigger system. So it's one of the real big beauties, I think, of citizen science, is taking these very little everyday things and bringing them to the forefront, because they actually do have importance, right? What about if 50 years from now, when that apples tree blooms, it's actually shifted by 10 days? What does that mean for the birds? When are the birds showing up? Are they tied to the photo period, and are they not coming at the same time as those trees are blooming? Or have they found a way to adapt and are coming at the same time as those trees? It's such a small thing that can have such cool impact. All right, so I'll leave that program alone, and I'll give one more nod, because this is, I would argue, even before I explicitly started studying citizen science, I knew about the Christmas bird count. It's also okay if you didn't. This is one that's also been running for more than 100 years now, and arguably one of the longest ones, not the earliest. It started in the 1900s, and it was started by a fellow named Frank Chapman. He was an ornithologist, and he realized that there was this sort of growing middle class, and that one thing he realized he could encourage with this was not to have people doing a Christmas bird hunt, but to change that into a Christmas bird count. So the very first one he did in the year 1900, there were 27 observers in 25 different places around the country, and they started at dusk and they went till dawn, and they did it for one day, and they found 90 different species, right? That's some pretty small, humble beginnings, which now has racked up. They've now identified more than 2,400 different species. They literally have thousands of observations every year, and it focuses on wintering sites. So it fills in this really cool gap of knowledge, because a lot of birding programs focus on breeding and mating. That's where it's easier to sort of collect information on. And so there have now been more than 54 birds counted. Sorry, that's more than 50 million each year. That's not in total. So that's a huge amount of information happening on a yearly basis. So maybe this is something that just becomes a part of your Christmas tradition. Maybe you're already a birder, maybe you're not. But spending a day outside will bring joy for you and for lots of other folks. Now, it's one thing to create 100 years of birding data, but what do people do with it? Well, one of the great things that they've been able to use it for is having early warning systems and getting long-term information about population health. So this is a couple examples. One is the American black duck, and they were actually able to track through the Christmas count data that these were declining, and then they limited the number of the hunting limit that you could take on them, and then the population was able to come back from that, right? Because think about it, all these birds are disconnected through space, but when they're migrating through, they are all the same connected population. So hunting in one place affects hunting in another. How do you keep track of the cumulative effects of that, right? But this data is one of those reasons that they were able to make better management choices. It also was one of the things that was able to track the decline in the Harris sparrow, right? And these are just a couple small examples that they've been able to use that data for. Another really cool one is that they're getting an idea of what climate change is having an effect on migratory routes and wintering locations. So what I mean by that is they have been able to find, I think for more than 100 different species, that their wintering location has shifted northwards by more than 100 miles. So we're seeing this shift. These birds are starting to find suitable habitat further and further north than they would have before. And so you can think about that for both understanding where are birds now, but also when you're trying to think about conservation, you're trying to think about how do I provide suitable habitat for these birds, you don't just need to think about how do I conserve where they are now, you need to start thinking about how do I make a healthy ecosystem for where they're going to be in 50 years, 80 years, right? Our world is always changing. Our climates have been changing for thousands of years, right? So that, or thousands, millennia, millions, as many as we can count. But our climate has been very different each of those times, and it's not always so kind to some species as it is to others, depending on which phase transition we're in. Excuse me. So some accountability for that is both, putting a heel on that change, or trying to close in that climate change as much as we can. And then also being accountable is also how do we deal with the outcomes from it, right? Trying to make choices that it's not just our species that makes it out the other side, if it is even ours. Sorry, that was a bit doomsday, but either way, take care of the earth, keep track of things. All right. Another big thing that's come out of this 100-year of data, which is important for this project, but is also just important for all citizen projects overall. So these kind of forefathers or four-parent projects have a big amount of effect in trust, right? One thing that is still literally an everyday battle is trying to get citizen science used by the scientists that were not involved in the project, by governing bodies, by decision makers, right? If we create all of this amazing useful data and no one ever looks at it, then what was it all for? And the reason why people don't look at it comes from a lack of faith, that people think that, oh, there's too much error in it, or they wouldn't know enough, or they haven't been highly trained enough in order to make accurate recordings. And there are some fields where this is true, or is still true based on the technology that we have. But this is twofold changing, both in the sense of technology and in the sense of, I want to say like human investment or capacity. I'm not sure which word to use there necessarily, but on the technology side, it is leveling the playing field. The ability to calibrate things, to have things on your smartphone, all of these things are becoming so much simpler and intuitive than they were 40, 70 years ago. There's so many calculations, even for the sensors that I use in my work. So many of the calculations are done in-house, and I only need to look at the surface numbers, right? So for what it takes to train me to use some of the sensors, I could train anyone on this call to do in a day, right? So that part is evening the playing field. And then I think the other part of it, like I try and think about this a lot. This is a joke that we make in grad school, is that it's not about being smart, it's just about whether or not you can persevere. Because it takes a lot, right, to commit to this one thing and really stick with it. And I think the take home that it came for me is that being a good scientist, yes, it does require, thinking things through, but it just requires commitment, right? So I could change that sentence very easily from, what does it take to make good science, right? It requires commitment. And so having a program that went for 100 years, true, it's on an individual level commitment, but that continued commitment inspires people to have confidence and to trust the data. So even on a small level, right, when people are signing up to do a citizen science project, there will be varying levels of commitment. But the core of it, if you get a core group that is committed, those are the ones that are going to pull you through and pull that data through. They're going to be consistent. They're going to remember the different steps for it. And so that's a big one. I kind of hope you walk away from today, is what, and this applies to citizen science, but it applies to all science, is building trust and knowledge is such an important and key step, right? And it's not that you shouldn't question it. You should 100% question where knowledge comes from. It's a huge part of creating good science, of making good planning, of existing in society in a way that makes sense. But it also, you kind of have to stack up this, the levels of commitment, and use that as a way to measure things, right? The more things that get behind something, the more support it has. Also, the more people that will then test it, right? It goes both ways. You want to put things in the limelight so that they can also have that back and forth and have those conversations. And so, yeah, I hope this is one way to sort of start rebuilding or building further trust in some of the science that's around you. And so citizen science, now that we had kind of those older projects that have created this window, this space in science in general, for it to expand, for it to just blow up. What started off as, a handful of birding projects and some weather and cloud monitoring data, has expanded into such a wide range, in so many different kinds and styles, in almost, I'm not going to say every sort of scientific area of study, but a lot of them have some component of it. So whatever interests you, whatever part of the world that you find fascinating, that you like the way to think about it ticks, there's probably some way for you to directly or indirectly create some of that knowledge, some of those things, those factoids that you think are so cool. So that's kind of what I want to shift into for this next little part, is I just want to just share some of the things that exist out there. And this is by no means an encompassing list. It's just some of the ones that I think are kind of good examples or good highlights, and some that have made some really cool headway over the years. So it kind of can split up into sort of longer running projects. There's some cyber components, and then there's more of a community component. And I'll try and touch on a few, at least a couple examples from each of these. So one really cool one out there for anyone in the world, wherever you might be, is the GLOBE program. And this is focusing on your clouds, believe it or not. They're those very whimsical clouds. If I look out my window today, I can't identify any individual. We've just got a full gray stratus. So pretty much it's gray clouds for me today, and it probably will be all day. But even though we have come so far with satellite technology, the fact is that clouds are very quickly changing, that it's happening on local scales that satellites cannot always cover or cannot always give the resolution both in time and space to actually make a difference for some of these things. So this is a way for us to fit in, if you want to think about this, the big picture, right? Clouds are absorbing and reflecting and scattering light, which is setting our whole energy balance. And this is one of the biggest things with climate change, is understanding how our cloud cover is going to change with changing climate. And so the more data we get on this, the better our whole understanding of literally our whole world will be. And really all it takes is a smartphone and a bit of time. You snap a photo, you can leave a few comments about the types of clouds that you see, you can describe them. And even at the very least, you snap a photo and you just pick send. And even that can go in and filter in into some really great observations passing on, right? Again, I will say a lot of these more observatory ones are based around having a smartphone, which I realize not everyone does. So I will talk about some other ways to participate in science. But again, it's just one of those technologies that has blown up and has created a huge vacuum, a huge space for this. So another really cool one is iNaturalist, which I wouldn't be surprised if even a few of you might already have on your phone, right? And all it takes is taking a picture of something, maybe a couple descriptors, and this can be on anything. iNaturalist is all about tracking biodiversity. It can be really common species, it can be something absolutely rare and you have no idea what it is, right? But by sharing this, it's creating this massive community that is now creating a data set for so many different scientists to come and to use. So as an example, from these images that are submitted, more than 150 scientific journal papers have been written from it, right? And that's on data that they would have never had access to otherwise. Not to bring us back to COVID in a sad way, but to show one of the cool things that came out of COVID. So during a lot of the lockdown, one of the things that scientists invited people to do was start transcribing data. So in the same way I talked about they were transcribing those old paper slips for the birding, they had them go through and they were able to get more than 350 years of weather data available and accessible for modern climate scientists to start using, which is amazing. I think that's one of those things where people, when we do glamorize science or we stereotype it, we put it in you're in a lab shaking a vial or you're typing away on a computer. A lot of science is not glamorous, right? I will spend many hours of my life editing Excel sheets and coding, and I do get to spend some of it in a beautiful river with people taking water samples, but I also spend a lot of it just kind of working away, right? This is what I mean by perseverance and commitment. It's a trudge. And so that's one of those things that so many people can contribute to that and get us moving down the line. This is another cool old weather one, but instead of being focused on place, or I should say this one is focused on place, this is focused on Arctic weather. So there's all these ships that when gathered, that they might have been going for different purposes, but lots of ships were loaded up with weather observation data, both for navigation and for their own records. So there's all this information that is existing in different libraries around the world, and it's not accessible. And so this is another really cool program. Again, think about instead of in the morning, you don't wake up and you read the newspaper for 20 minutes, maybe you just wake up in the morning, get your cup of coffee, sit down, and you read some really cool observations from someone in 1847 about what their day was like and what the weather was doing. And you write that down and you pass that information on. Think about how you could change those little snippets of your time and your day and your life. Some of it, again, we can kind of zoom us into more in the present. And this is actually a cool one. I'd forgotten about this, but I was at McGill when they started developing this program. So this is one to have people start helping track genetic diseases. The idea being that the colors are matching different base pairs, and it's a game that you play. Like if you like playing Tetris, if you like those different puzzle games on your phone, you could be spending that time actually matching to genetic diseases, or you could be developing RNA-based vaccines, right? So it's, again, they've put it in a platform that you can think about it as a game, and you're problem solving your way through it, looking for different configurations. There are so many unique parameters that it does take someone actually going through and like moving the puzzle pieces in order to see if it will pair up. Another cool one, maybe if you don't want to sit inside on your house, maybe you happen to live on the coast, maybe you're a surfer, maybe you're a boater. This is a really cool one called SmartFin, where they have created sensors that fit, or they've created special fins to go on surfboards that are full of sensors to measure water chemistry, temperature, things like that. And so literally just by going and doing that thing you were already doing, nothing has to change about it. You are now collecting data that can be fed back into a global range on a lot of these coastal environments that are so integral to different places. So all these dots here give you an idea of where people have collected data, right? Some of them had them on their boats. Some of the people had the fins on their boats. Some of them had them on their surfboards. And all you have to do, right, really, you just go and do what you're doing and you make sure the data uploads. That's the only extra step in your life that it would take. While I'm on the marine section, this I just think is this is such a really cool one and a really fun one. But you know, if you maybe you're more of a whale person or a dolphin person, I'm certainly fascinated by different human languages, but you can also dial in on learning some whale speak after a fashion, right? So tracking different patterns and identifying different cue points. They teach you pattern recognition, and then they teach you different sounds to hit. There's a couple projects here that are an example. There's the Song Whale project, also known as Whale FM, and then there's the Setalingua project. Right? There is so much data that these centers pick up. And I have friends who do this. And yes, they do have algorithms that go and filter through a lot of it. But at the end of the day, I know people who spend hours of their life listening to whale songs. My friend who was doing her master's, when we weren't working, she was just sitting in her hotel room listening to narwhals. That's what she did, because that's what she had to get through to get her master's done, right? So it's not, and that part wasn't, I mean, it takes a little bit of training, but can get you there. So that's an auditory one. Let's say for some reason this year you weren't able to go on a safari, or you weren't able to travel to see some of those amazing creatures, or maybe you've never been able to, right? But you want to see what their life is really like. Well, get into Snapshot Safari. There are camera traps all around in different research programs. And the same thing I said, we have algorithms that can filter through it, but at the end of the day, someone still has to look at every single photo, identify behavior, traits, numbers, things like that. And that information is so valuable. Again, I know people who this was their job. We would leave camera traps out all summer, and then one or two of us techs would be hired on to spend literally months filtering through pictures like this. So this is real science. Like, this is 100% it. It goes both ways. And again, if you don't want to be the stationary one, if you want to be the one going and getting the data, by all means, there are so many avenues for that. This is a really great one. This one was started up in New York. It's called I See Mammals. And again, if you're already going on a hike, if you're already doing these things, you can observe the signs of different animals that you see. You can explain the trails that you're going on, and even the fact that you didn't see one during that time is still information, right? These are all experiences. Experiences become data once you up it and you record it in some form or fashion, which is also why data takes many different forms. And we always tend to think about it as spreadsheets and numbers, but there's data that we hold on to in lots of different ways too. I just want to give a nod to that because I know I'm really focusing heavily on that traditional source of data that people think about. This is another great one. If you take a beautiful picture of a butterfly, all you need is the picture, the location, and the time. And you can upload that, and you can fit that into a whole bunch of other data that they're using to track butterflies and moths all across North America. These are things that you probably already have done, right? You probably wake up and you see that really beautiful butterfly on your doorstep, and you can't help but get your phone and take a photo. It's only a few more steps after that to have that beautiful memory of yours being helpful for someone else. And some of these projects provide great, not only education and that data collection, but then also solutions too. I really love this one. This one is called the Great Sunflower Project. And this is focusing on pollinators. It has more than 100,000 members, the largest citizen science project that's focused on pollinators. So they have some of it that's about identification. If you contact the website, they'll give you a little bee identification card so that you can start identifying the bees in your area. They will also give you prompts and cues for things to start growing in your garden. What is safe and helpful? How do you help bees get through different seasons, right? I know lots of folks are not big fans of dandelions, but dandelions are a huge integral part to early season pollination, right? So the bees need different flowers that are blooming throughout the summer. And if we start axing out different steps, you're actually starving the bees through different stages of their life cycle. So it teaches you to look at what you already see in a much different way and hopefully value it in a different way as well. They also do work with pesticides if you want to tap into one of those programs they have running. And some of them are even come down to your own health, right? I mean, I think our own health is intrinsically tied to our ecosystem. But if you want to even just remove the degrees, you can use this to start keeping track and helping your community, right? So this is a really cool one. It's called Crowd the Tap. And it's the idea that with really just a couple things, you can check on the infrastructure of your own taps, of your community lines to see when does it need to be replaced. Also, a lot of these have been designed over different eras that are using different materials that are no longer healthy for us. And if you upload that information into a bigger portal, then they can actually start directing where funds need to go in order to make some of those renovations in a time that's helpful for people. This one I think is a really cool one in an urban setting. So this was in, I think this was in Belgium. Oh boy, I gotta remember. I'm pretty sure, yeah. Sorry, my brain was running slow there for a second. I just can't, or Antwerp, there we go. I was trying to remember the city. So they handed out, they contacted, or they advertised throughout the city, they handed out more than 20,000 air monitors, air temperature monitor, or not, sorry, air quality monitors. They were going for nitrates or nitrous oxide. It was a nitrogen based, but that's what they're trying to see for air quality. And it's on a level that that low to the ground, nitrogen dioxide, there we go, that satellites can't pick that up. And so they sent out 20,000 sensors and they got 99% of them back, and they got 17,000 valid and useful air quality parameters that they were able to then understand their city with. How amazing is that? And it was 1 month, right? It was advertised and it was pulled together, and anyone could come in and pick up a sensor, and then they just dropped it back off. Like, how, I'm just so amazed by that. And I think it's such a great precedent. That's on, a small scale. You can also zoom out onto global scales. There's lots of really great projects happening. There's one that was formerly known as World Water Monitoring Challenge, but now it's called the Earth Echo Water Challenge. And it's actually started by the descendants of Jacques Cousteau. So his grandchildren, sort of to honor their dad, they wanted a way for youth to be able to have some autonomy, right? And so they will, if you contact them, they will send out a kit. That kit will be able to measure a lot of different water parameters, and then send it back. And that's one of the ways to sort of, start having some control and some support also for what your own community is facing, and connecting up to other communities as well, and getting problems at large. And if encompassing this world isn't enough for you, we can even go out into space, right? Again, so much of these things need to get processed, and it takes so much time, regardless of the world we're living in. So this is an example from 2017. It was the Kepler Space Telescope. Thousands of citizen scientists signed up to help process the data. Excuse me. And by the end, they found whole new planet systems, or an exoplanet system. So it all paid off, right? Yeah, and that was again just everyday people, instead of maybe sitting down and watching Netflix, took a half an hour every week and looked through photos of stars. It's not a bad way. And this one I also think is so freaking cool. This is one of the things, once you start digging into this, some of these I knew about beforehand, but some of these are brand new to me, and I just think they're so much fun. And it kind of speaks to the kid in all of us, but also this one is fun and super functional. So for anyone out there who got onto the sourdough train during COVID, or who was already a big sourdough fan, even though that there's very unlikely anyone on this call who's never eaten bread. And even if you're celiac, you probably figured out you were celiac because you ate some form of bread. So this is one of those things that is so commonplace and is actually not as well understood as you might think, because yeast and those bacteria are extremely local, right? So I could collect bacteria from the air in this room and it would make a different sort of bread yeast or starter than it would if I went out into the forest and collected bacteria from there. And there's people who actually study this. This is a legit area of study, right? But they encourage people to start their own starters to track its growth, its temperature, do it for a couple weeks, and then you send that information in. And then at the end of it, you have your own sourdough starter that you can keep going, or maybe you give to the neighbor, either way. But all of that is functional fun. I just think it's so great. And it shows us that there's still lots of wonder left in our world, even in places that we think we've got all figured out. This is a couple examples. I'm going to shift gears a little bit. So those are kind of big group, big project examples. But I also just want to highlight a couple really amazing stories. One I've been inspired by for a long time, and one I only discovered when I started researching for this webinar. So the man you see there is very famous, or at least he is in my books. His name is Wilson Bentley. He was born in 1865, and he was the first person to ever photograph a snowflake, and he did it at about the age of 18 or 19. So he grew up, or I guess when he was 15, he got, I can't remember if it was 15, he got his first microscope or his first camera. I think his first microscope. And he became really fascinated with snowflakes. And so after 4 years later, he took his microscope and his camera, and he took the first picture anyone had ever taken of a snowflake. And so that first photo was in 1885. Through the course of his life, he would photograph more than 5,000 snow crystals, all the way, pretty much all the way up until his death in 1931. And so I grew up saying and knowing that every snowflake is unique. That is, if, at least for anyone who lives in cold climates, we all know that. What you didn't know is the reason why we know that is because of a teenage boy and a microscope and a camera. That is the reason we know that. How amazing is that? This fundamental piece of arguably quite aesthetic and beautiful knowledge, and what that means, right? It does, in the way that ice forms and functions, is because someone just took a real genuine interest in their environment. And yeah, I remember learning that. I don't know if I learned that in high school or if I learned that in university, but this has always been such a beautiful story of inspiration for me. This one is much more recent, and I actually didn't realize this until finding out in the news, but there is an amateur archaeologist, a fellow by the name of Ben Bacon, and I'm guessing he probably made the discoveries in the last couple years, but they didn't really make it into the news articles until the beginning of 23. And what Ben discovered was actually an earlier writing system that exists than anything else anyone has ever known. And he found it in Ice Age cave paintings in Europe. So Ben, or Mr. Bacon, he lives in the UK. He works with furniture. I can't remember if he's a furniture repairman or if he constructs them himself, but you can kind of see all the tools in the background there where they picked for that photo. And yeah, he really loved archaeology. And so in his spare time, his hobby was he was going through all these photos of these different cave paintings from around Europe, and he started noticing these dot systems. And that all of these different animals had different sequences of dots, and that they actually tied into their life cycle. So what he found was that all these cave paintings, they tied up the lunar cycle with when the animal either mated or gave birth, right? Which is incredible. This is basically 10,000 years before anyone else thought there was a written system. We now know that people living in caves were tracking time, right, as an earlier system. And then some of the different symbols they had, I don't know if it's in this one or not. So the straight lines are for, I think what he said was mating, and then like anywhere there was a Y, that was for birth, right? But these animals are their whole source of life and source of culture. And And so this is the earliest piece of information we have that shows that humans were not just living in the present, that they understood time, right? Which is another thing to keep in mind. We often think about our pets and our animals and, are they just living in the present, right? But we don't actually understand how they're processing time themselves in the same way. So an amazing discovery by someone who took an interest. And I'll be a bit biased today, and I just wanted to end. A lot of these maybe seem like faraway places or faraway things, but I just wanted to bring it back to the community that I work with. So I work here on Vancouver Island. Over the course of 3 years, I've worked with about 50 different, we call them community scientists or volunteers, or that's who our volunteers are. And they go out every week in the summertime. They have a little route, takes them usually like an hour. Well, it depends who goes, but a couple hours. And they go out, they take the water samples, and they come back and they bring it in. They're measuring their temperature, they're measuring the mineral content, and we're using that to track sort of drought resilience. This is one of the places in the world where our streams are drying up, both due to water use, changes in land use, and our climate. And so there are some of the ones, and it's actually cool. I was just at a partner meeting yesterday, and we're really working hard to have this data used by our provincial government, by our local First Nation, to changing how it's going to be managed based on the information that these people have collected and that these people have helped understand. So we focus on groundwater, and the reason why it's just one to bring up is that groundwater is something that we can't see, right? It's underneath our feet and has this relationship to surface water, and we really care about the surface water. People love their lakes, they love their rivers, and so even just the fact that we're working with community is one of those things that is tying in this idea that, what am I trying to say here? That the groundwater, if you're going to love your lake or your river, you have to love your groundwater too. You have to either love what your stream is feeding into the ground, so that's that middle one, what we call a losing stream, or what your stream is getting from the ground, so we call gaining streams. And so we're starting to sort of teach people. This is a funny analogy, but I quite like it. So if you think about your layers of your groundwater, like layers in a cake, it's not all the same, right? Some of it comes from the top layer of your cake, some of it comes from the bottom layer, some of it comes from the middle layer. And so as we get under drought stress, we start to rely more and more on different layers of our groundwater cake. And so starting to get that idea across to people will hopefully help them make choices about how long they're irrigating their fields for, or when they're running, whether they're having pools, whether they're watering their lawn, right? If they start to understand where their water is coming from and how that affects the river, then hopefully they can make the right choices just within community, forgetting about whatever governing body might participate. That's some of those changes, that we hope it can and will get to making. So I've covered quite a few things. I'm going to wrap this up here with just one last little notion. I know as I've kind of talked that I've gone from really broad general projects that are kind of distant to more and more levels of engagement. And this is one of the ways that in our scientific community we kind of track that, is this, they call it the escalator of engagement. And it's sort of funny because I completely disagree with this. And I wasn't going to use it, I was going to find something else. But sometimes I realize that there's more value in explaining why you disagree with something than if you just don't include it. So this shows this, to me, when I look at an escalator, the idea of going up is a sense of improvement, a sense that, the bottom level is the least level of, good, and the top level is the most level of good. And I think that is not true at all. I think that all of these provide great value in different ways and fit into your life in different ways. And I'm going to use a very funny example of that, because this same thing exists in relationships. They call it the relationship escalator, and the idea being that there's this order of things that you do things in, and you meet someone, and then you fall in love, and then you become a couple, and then you get married, and then you buy a house. But I know lots of people who went on a date, and then they had a kid, and maybe they got together, and maybe they didn't, and maybe you never buy a house, or maybe you do. And so it's not linear, right? We're getting better in our society. Like, my mom had my sister before she was born, and she was born in a time where that was not okay, and my mom was shunned for that. And I think that's terrible and awful. Right? Because she didn't follow the escalator. My mom was not on the escalator, and society penalized her for that. So I grew up thinking this escalator doesn't make any sense. I don't think it works, right? And I think the same thing is true when you think about levels of engagement. So for any folks who are sitting out there thinking, I want to do this, or I want to do something, but I don't know how much I can do, or maybe I can, or maybe I can't, in my mind, if we go back to the citizen science part, if you are a citizen, if you exist in this world, you care about it, or you need to care about it. And I hope there's something you care about. And you can pick the thing that you love the most. Go ahead and be biased. If you love whales, if you love butterflies, if you love to swim, pick the thing that you love and find a way to take care of that thing. I think that's what the bottom line is. And you can do it at any of these levels of engagement. You can be the one out there in the mucky boots, digging through the wetland looking for awesome frogs. Or you can be the one sitting in your computer who's solving puzzles, working on RNA. But if everybody just picks up one piece of the puzzle, think about how much amazing change we could do. And that's the note I'm going to leave it on. With respect to him, I'm going to pass it back over to Sunny.
Kristina, thank you so much. You always bring us such fascinating topics and help us see it through a new lens. So thank you for reframing and mystifying science and encouraging us to reclaim our curiosity and play and sense of discovery and participate in this process of observing and learning and really seeing our world in a different way, because we all see something different. So thank you for getting meta with us today. We have some great questions, but I know we just have a little bit of time, so let's squeeze in one or two. Are you aware of any citizen scientist programs with monarch butterflies?
Yes, there's the monarch tagging program, which I don't know the specific name of, but you can find it, and you essentially are leaving little tiny stickers. You participate in the program, and then you can actually sticker your monarch, and then people can track your monarch. So if you want to find that one, please dig into it. I think you might even find some of that on the NatHab website, because I know I've talked about it with some of the people who guide down there. But yeah, there definitely is. It's very, very cool. Please dig into it.
And are you aware of any opportunities for folks who are not super technically savvy? Like, would
Yeah,
they just
and
be
so
looking more locally?
I would say start local for one thing. And if you're not tech savvy, that's totally fine. The trick is finding them in the first place. So it's easier to find local programs, but even a lot of these, and even including the program that I run, like, yes, I run it off of smartphones, but we have the data sheets for anyone who doesn't want to use a phone. And half of my folks use them, and then I've got the other half of the team that helps them put in the data later. And so there still is an avenue for that. I would say also, if you're not tech savvy, then look for a sampling thing. Look for where you're not the person who's entering the data, but you're the person who goes out once a month and takes the sample and just sends it off to a lab. That's a really great way. It might be a bit techy. You might need help finding that program at first, but then you can have it set up where, once a month, once a week, maybe it's only a handful of times a year, but I think if that's a great hands-on way to participate. And this is the part where I am going to throw the onus on each and every one of you, is that I could put together a list, sure, of 12 projects I think are great that you could all go and use. But the reality is that part of being accountable for your actions is going, and you do have to do the legwork. I'm going to throw that one towards you guys. You have to do the legwork to find something, both in order to do something meaningful, but also to have it meaningful for you. So, set aside some time to go looking. It'll be worthwhile.
Well, that's the last question we have time for today, so I will hand it back. That sounded like a great closing comment, but just in case you have something else, I'll pass it back to you.
I just want to say thank you, a lot of gratitude for everyone who's been showing up to these, and who's been sharing your curiosity or piqued your curiosity. And yeah, I hope, sort of near or far, find a really beautiful way to take care of yourselves, your family, your planet, and we'll all get there. That's the goal, right?
Well, thank you again for presenting and for bringing us just such a thoughtful topic. The comments reflect their appreciation for your work and for your passion. So I will make sure you get to read those later. I also want to thank everybody who tuned in. Please join us again tomorrow for our next Daily Dose of Nature. You can check out this week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude the webinar. Have a wonderful day, everyone.